Hello, everybody, and welcome back. We've got another visual pattern challenge for you today. Here's step one of this pattern. Here's step two, and here's step three. And your challenge is to look at this pattern and see if you can predict how many of these green rectangles are going to be in step number four. And if you can manage that, then how many do you think are going to be in step number 43? And along the way, can you write an equation that you could use to predict the number of green rectangles in any step at all? If you'd like to accept that challenge, pause the video and work it out. All right, well, I think this is an odd looking pattern, and I'm not sure the visual on this is going to give us a lot of easy clues. So we may have to just analyze the numbers. What I'm noticing visually is that we start with 1, and then I guess maybe we can think of the 1 being here in the center, and we've built off of the 4 corners. So we've added this row of 2 on the top and row of 2 on the bottom. And then that pattern is right there in the middle. And then we've got a row of 3 on the top and a row of 3 on the bottom. So we've added those 6 to the next step in this sort of checkerboard every other pattern. So if I were to predict, we've got a row of 1 here and then a row of 2 rows of 2, and then 2 rows of 3. So in the next step, I think we're going to add a row of 4 on the top and a row of 4 on the bottom. So for step 4, I think this is how many we're going to have, however many that is. So this is 7, 9, 10. So that is 19 for step 4. All right, so that's our prediction for step 4. But what is really going on in this pattern? Is it linear? Is it quadratic? Is it something else? Let's approach that by just analyzing the number first. So I'm going to put the step number in a chart and then the number of rectangles. So in step 1, we've got 1. In step 2, that's 5. In step 3, we add 6 more, so that is 11. And in step 4, we add 8 more, so that's 19, as we predicted. Okay. Once we've got our numbers arranged in a chart, we can take the differences between each step, see how much is being added each step. So 5 minus 1 is 4, 11 minus 5 is 6, and 19 minus 11 is 8. So this is not a constant. The differences, it changes every step. So what we know is it's not a linear pattern. We can take the difference of the differences, and if this comes out as a constant, then we know we have a quadratic. So 6 minus 4 is 2, 8 minus 6 is 2. Aha. So in the second level of differences, if that's a constant, you've got a quadratic. And this 2 here, I know means that we have an x squared. Now, at this point, it's a little hard to see how x squared applies visually here. I could try blocking out an x squared, but it would look kind of messy and not very sensical. So I think I'm actually going to just look at my numbers here. So I'm actually going to make a new chart where I can think about this. So we've got our step and our number of rects. So in step 1, we've got 1. And actually what I'm going to do is figure out what an x squared is. So I've got 1 squared, and that's actually it. That's all I need. In 2, I have a 2 squared. Now that would make 4, so I'd have 1 left over. So 2 squared is 4, plus 1 is 5, so that equals the number of rectangles in step 2. In 3, I've got the step number squared, and then I'd need 2 more. And then in step 4, I've got the step number squared, and I would need 3 more to get to 19. 4 squared is 16 plus 3 is 19. When I arrange it this way, I can see a pretty clear pattern. And actually, I'm going to make this plus 0 just to make that even more consistent as a pattern. So it looks to me what I'm doing is I'm squaring the step number, and then I'm adding 1 less than the step number, right? So in step 2, you add 1. In step 3, you add 2. So if I'm going to write that out as an equation, I could say there's the x squared part, and then we add the step number minus 1. Now we don't really need these parentheses here, but I just wanted to do that to make the two parts of this clear. We can rewrite our equation down here as y equals x squared plus x minus 1. I think that's the equation, but let's test it. Let's make sure it's really working. So in step 1, it would be 1 squared, and then plus x is plus the step number, and then minus 1. So that's 1 plus 1 minus 1. That's going to be 1. In the next step, in step 2, we have 2 squared plus the step number minus 1. 4 plus 2 is 6, minus 1 is 5. And in step 3, 3 squared minus the step number, plus the step number minus 1. That's 9 plus 3 is 12, minus 1 is 11. That's all matching up with what we're seeing here. So this equation looks pretty good to me. Now, to figure out how many rectangles in step 43, we just have to plug in 43 for x. So this is going to be y equals 43 squared plus 43 minus 1. And 43 squared is 1,849. And then 43 minus 1 is 42. So we're adding 42. So it looks like we're getting 1,891 green rectangles in step 43. Well, how did that go for you? I think this is a pretty tough one. It's hard to see the pattern visually. Were you able to get a hint of it by figuring out that it was a quadratic? And were you able to see this pattern in the numbers? Let me know. Thanks, everybody.